Welcome back. In this video, we're bringing you an interview with Xavier Amatriain from Netflix to talk about learning to rank and problems with doing recommendation in situations where users are clicking and viewing things and not necessarily providing a lot of explicit ratings. Xavier, welcome to the course.
Thank you. Great to be here.
So what does Netflix do with recommendation?
Okay, so for those of you who don't know, Netflix is a online streaming service where you pay a monthly fee and then you get access to a whole catalog of videos that include movies and TV shows. Our whole service and UI is kind of designed around the concept of recommendations. In our case, more than 75% of what people choose come from our recommendations. And as a matter of fact, as opposed to many other services, for us, search is a much less important concept. We think of search as that thing that people do whenever we're not good enough in giving them recommendations. And again, over 75 to 80% of what people watch on Netflix comes from our recommendation algorithms, which mean that they're very core to our business proposition.
So can we see an example of this interface?
Yes, sure. So first, let's look at some of these slides, and let me start by saying that Netflix works on many different devices. We have hundreds of different devices, but the basic idea here, we're seeing the iPad interface, for example, but the basic idea is always the same. We have rows and we have ranking in the rows. So if you think about it, this introduces two different concepts and two different ways to address the recommendation problem, which are key to our service. One of them is how to select those rows, and those rows usually represent a genre or a mood we think the user might be in. And then the other one, which is core to what we do and to what many recommendation systems do, is the ranking, right? It's how you select and how do you sort the items that are going to be presented in each of these rows. And again, what we're seeing now is the web interface. But if we go to the phone, for example, and you look to the iPhone interface, the concept is basically the same. You still have rows which have been selected, and then you have items in the rows that have been ranked. And of course, the number of items that you capture in a screen depend on the device and so on. But the basic idea is the same. It's rows and then ranking in the rows. So if we go into one of these rows, for example, we have rows like the top 10 row, and that's one of the rows that we usually pin on the top of the page, and we try to select only 10 items, those 10 items that I think are more that we think are most representative of what the user might be interested in watching right now. We introduce concepts like introducing diversity and freshness. We also have other rows like popular Netflix row, where in this case, even though we call the row popular on Netflix, it's also personalized. So as a matter of fact, all the rows that you'll get in your homepage are going to be personalized. The ranking is going to be personalized. And even each of the rows that you're getting, the ones that we were talking about represent some genre or some mood you might be in, they're also personalized, and they respond, and you can see that on the left of each rows here in this screen capture. They respond to some implicit or explicit feedback, things that you've watched before or things that you've told us that you usually like to watch. And again, they're also personalized. And that's why, as I was saying in the beginning, over 75% of what you're going to end up watching comes from some sort of recommendation.
When Netflix presents a recommendation to a user, what is the goal of that recommendation? What response do you want the user, or experience do you want the user to have in response to the recommendation?
Yeah, so that's a very good question, and that gets us to the core of what are we trying to optimize when we build these recommendation systems. And the basic idea is when we're presenting something to the user, we're trying to get the user to watch something. And that might seem trivial, but there's a lot in there. And for example, we're not only trying to get the user to click on the item, but we're trying to get the user engaged in something that is interesting, at least for a long time, meaning that the user clicks on it and continues watching for some time. And in some sense, our systems and our algorithms, what we're trying to do is to optimize the amount of hours that the user engages with the service, right? And that means that we're presenting things the user likes, the user, of course, clicks on, but then continues to watch for some time. And the reason we do that is because we know that correlates very well with what one of the business core objectives, which is to retain users over time, right? So we're not only interested in tricking you into clicking something that you might not like. We're actually trying to optimize overall over a long period of time how many hours you're going to be watching, and that gets us to the, again, to the objective that we're trying to optimize, and the objective function that we're trying to optimize when we build these recommendation algorithms.
So I don't hear anything about rating prediction in there. And a lot of the algorithms that we've looked at so far in this course, they start by trying to predict ratings. And even if we're going to recommend 5 items to the user, we do so by predicting ratings or otherwise estimating the preference for each item and then just picking the 5 best ones.
Yeah.
So does that work for the goals you're trying to optimize? And if not, why isn't it adequate or appropriate?
Yes, it's a very good question because we've been working on recommendation systems at Netflix for a long time, and we've been there, and by been there meaning optimizing the predicted rating was our core metric some time ago, specifically when we presented the Netflix prize, right, in 2006. Now, the key idea is that what we were trying to optimize there was different because our service was different in that at that time we were actually doing DVD by mail, and that's a very different service where people were actually putting a lot of thought into deciding what they wanted because they were going to receive it 2 days afterwards, and they were trying to think, what will I want to watch during the weekend? And then they put a lot of effort in giving us some good feedback because they knew that that was going to influence what we were recommending. Now, in our case right now, what we've seen over time is that the quality of the explicit feedback that we get has gone down for many different reasons. First of all, people don't engage so much in giving you explicit feedback when they're in a service where they can very quickly change their decision. And that happens when you're in a service like Netflix where you have instant streaming. If you start watching something and you don't like it, what you will do is switch to something else. You won't stop, give us a bad rating, and then try to make another decision, right? So the process becomes very different. You don't put so much effort in giving explicit feedback. You assume that your actions and what you're doing there are informing the system. And what we've seen over time is that we get less explicit feedback, and the explicit feedback that we get on the ratings is also worse quality. There's an added problem here that we have in services like Netflix, where we have an account that actually represents a whole household. And there, what we see is that the kind of feedback that we get through the explicit feedback is sort of a mix of what the different people in the household get. And it's actually worse than a mix. We might have the adults in the household trying to rate all the kids' content very lowly because they want it to go away. But of course, the kids want to watch that, so they will go and do a different thing. And for example, kids are known to be very bimodal in their ratings, and many of them will actually only give 5-star ratings to what they watch. They will either not rate or give. And overall, the quality and the coverage of our explicit feedback has gone down. On the other hand, we now have a ton of implicit feedback that is very good and we can use in our recommendation algorithms. So that's not to say we don't use ratings, but first of all, we're not optimizing for ratings because that's not our goal. Our goal is not to understand what is the next thing you're going to be rating highly. Because, for example, and that's another important issue, you might rate highly foreign films and documentaries, but that's something that you only watch 10% of the time, and you still think they're very good. But 90% of the other time, you're going to be watching just an easy comedy because you're tired after work and all you want to do is relax and enjoy some time. And you will maybe rate that lowly, but you still, 5 days out of the 7 of the week, you're going to be watching something that you consider is not very good, but it's entertaining, right?
Yeah, I find that a lot myself, that the 5-star ratings are serious dramas or high art films, and most of the time I want a 4-star action movie if I just want to have fun in the evening.
Exactly, yeah.
So the goal, it seems, is to blend the likelihood that the person is going to watch something, either gross popularity or in some personalized fashion, with personalized factors like what particular things that they want to watch. Mm-hmm. How do you go about doing this?
Yes. And that's exactly, I think, a good way to think about it. If you think about the ranking problem in an abstract sense, and you want to build a very, very trivial ranking algorithm, and you go into a room and you say, hey, build a ranking algorithm for these people that you don't know, the best thing you can do is take popularity as your baseline, right? You look at your service, you take the most popular items, and you present the same items to everyone, because chances are that if you pick the most popular things, you're going to be covering a good percentage of the people that are in the room, because by definition, popular items are those that most people tend to enjoy or watch, right? So popularity is always a very good baseline to think about when you're starting a ranking problem. And then the key thing is, okay, what can I add to that popularity that makes it more personalized? Because, of course, popularity is the opposite from recommendation and from personalization, which is what we're trying to get at, right? So think about it this way. What do we have at hand that can help us personalize a ranking signal? And as we were just talking before, rating prediction might be actually a very good signal to use. So we can now blend popularity, which is unpersonalized, with the rating prediction signal that we've been working on, I know for a good part of this course, and take that now not as an objective function, but actually as an input feature to our ranking algorithm, right? A good way to think about it is, think about this as a two-dimensional space, right? Where we have popularity of a movie in one of the axes and the predicted rating for a given user, of course, because that's personalized, on the other axis, right? And we need to build a model that actually combines those two things. So the simplest thing we can do is think of a linear model. And this linear model is going to be combining those two features, the popularity of a video and the rating of a video giving a user. We're going to be giving some weights to those two components, and there's going to be a bias term. And that actually defines a line in this two-dimensional space, right? If depending on the weights that we are going to give to W1, W2, that's going to have a different slope. Let's pretend that it has this slope. And now what we can do is all the items we have in the two-dimensional space, we can project them into this linear model, and they will fall somewhere into this line, and that actually ends up defining our final ranking. So we basically take those projections into the two-dimensional space, or basically just evaluating the score given the values and the weights, and then we sort. Finally, we sort the items according to those scores, and that gives us the final ranking. So again, this is a very simple approach to building your first ranking model. It's a linear model where you're using these two different features. One of them is giving you the baseline, which is the popularity, which is a very good baseline to have and to think about. And then another personalized feature, in this case, the predicted rating that you've built, however you build your rating prediction algorithm. And all that is left now, and it's not a trivial thing, and it's the learning to rank problem, is how do you determine the weight you give to each of those two features, right? We had the W1, the W2. Those are the relative weights that you're going to give. And the question you have to answer is, in my particular case, is popularity more relevant than predicted rating, or the other way around? What's the relative merit of each of these two features? And of course, the key issue here is you should let the data you have speak for itself, and build some learning algorithm that is able to determine those weights by looking at the data you have.
So how might we go about learning these weights?
Okay, so there are many ways, but the simplest approach would be to treat this as a classification problem. This is the so-called point-wise approach to learning to rank, right? So basically, instead of building a ranking, treating it as a ranking problem, we might treat it as a classification problem where we have two classes. We have the positive examples, so it's a one class, the positive examples and the negative examples. And we basically try to learn that function as a function that separates the positive from the negative examples. So one simple approach to this would be using something like logistic regression. You're treating, and logistic regression, some of you might know, is a regression algorithm in which, by using a logic function, you're converting it into a classification algorithm. And the basic idea here is that you have your positive examples, which are going to be the things that people clicked on, or in our case, the things that people watched. Your negative examples, which are the things that people didn't watch. And then you train your classifier to try to optimize the function that separates those positive examples from those negative examples. In the process of training your classifier by using some iterative algorithm like gradient descent or a similar one, you are going to be determining those weights in the linear model that are actually defining that that boundary between the two classes. And that's what you're going to be using then to determine the score for your ranking function. So basically, the simplest approach is to treat that as a classification problem and use something like logistic regression to learn the linear function. And that's a linear approach. Of course, there's other ways to learn a classifier that are nonlinear, and you can go into using decision trees, for example, in a similar way as you would do with logistic regression.
So if I have some data of, say, movies people watched and didn't watch, or started watching and stopped real soon, and popularity data and predicted rating, I could put that into R and ask it to give me a logistic regression over the popularity, the predicted rating, to predict whether they watched it, and that would let me start experimenting with this recommendation technique.
Exactly. Yeah.
So if people want to go do more reading about either this approach or more sophisticated approaches to this problem to experiment with or try in their own systems, what should they go looking for?
Yeah. So I think that the key word that they should be looking for is learning to rank, and in particular, personalized learning to rank. There's different approaches that go from the pairwise approach to learning to rank to the more advanced list-wise approaches. Now, why is the classification approach not good enough in many cases? The classification approach has an issue, which is that what you're optimizing when you're learning your algorithm is something like the log likelihood, which is not a ranking metric. And what you ideally would want to do is optimize some ranking metric that really represents your problem. And ranking metrics like NDCG or mean reciprocal rank or fraction of concordant pairs, those are more related to what you're trying to optimize. The problem with those metrics is that they're not differentiable. They're hard to optimize in a gradient descent scenario, and then you have to be smarter about it. And there's a lot of smart people doing research around these topics. So I recommend you look into learning to rank pairwise and list-wise approaches. I think in the course you might also get a link to a blog post that I have where I go through some of these methods and some pointers to some of the reading that you might be interested if you are interested in those more advanced approaches.
Yeah, and a link to that post will be in the course readings list.
Okay, good.
So thank you for joining us.
Thank you very much.